So as for the down counter, you can go back to our tab here and choose CTD. All right. So let's see here. So we delete the count up. Okay. All right. So we put C5 1 for example, and also represent 5 for example. Okay. So for the down counters, instead of CU, we can use CD for countdown. Right. And we also have the done bit, and for the countdown we have the underflow. Okay, underflow. All right, so similar to count up, so now it's the reverse, so it will count down now. All right, so let's try to simulate this counter. So we download, all right, and run. So the counters always go high whenever you have the transition from false to true in the input round. Okay, so from false to true, we will have the signal here making the counter true, and then you have the countdown bit now is enabled, therefore it will turn on the output, and you can see that the accumulator is now counting down. So from 0 is counting to -1, right? And then -2, -3, -4, and so on. Okay, so if you can see here, if you are aware, so we will never be able to make this done bit true, no, because this one will, the accumulator will never match the preset value. So we can, we can either change the value of our accumulator to be more than preset. So for example 10. All right, so we download and run. So you go from 10, 9, 8, 7, 6, okay, 5. Right, so you can see that the done bit is behaves exactly similar with the up counters, meaning that it will be true whenever the accumulator value is equal or more than the preset. Right, so as you can see, now the accumulator is more than preset 6, where the preset is 5. Now the done bit is true, right? So we go again, and 5 still true because it will be true whenever the accumulator is equals to preset, right? And we go one more, so you can see that the accumulator is less than preset. Now the done bit will be false. Okay, therefore the output is also false. Okay, so that's the difference and similarity between the down counter and up counter. So you can see here, for you have another bit here which is underflow. So if you go to the definition of the underflow bit, you can see that it will be true if the accumulator is less than -32,768. All right, so let's say we put here -32,766. Okay, download, run. Right, so it's counting down 32,767, and then 32,768. We go one more, and then you can see that the UN or underflow bits will be true, therefore it will turn on the output. And then you can see also the done bit of this counter will be true whenever the underflow bits is true. Okay, so you might be wondering what is the main purpose of counting down, right? So because it's not very intuitive compared to counting up. All right, so the fact is that it is very useful when it is used with the up counter. All right, so let's add one rung for the up counter, so to see the situation which the down counter is very useful. All right, so we can copy this rung and paste rung below. Okay, so let's change this to counter up. Okay, so we delete this up, right? So in fact, for up and down counters, it can share the same address of counters. So let's say your down counter here is C51. So for the up counter, you can exactly use same address. Okay. So let's say the preset is so 5, right? So accumulator is 0. Okay. So accumulator is 0. Okay. So we can add one more. For example, copy around below. So maybe we put this as CU, okay, and change another output, okay. So let's try to simulate this, download and run. So okay, so you can see that the input is the same now, so we don't want that one. So let's change to this input to see more clearly how this one behaves. Okay, download and run. Okay, so now the counter is up. So you can see that the accumulator of CTD follows the CTU, right? So count up. So this one will be true. Therefore, the up counter is true. So the accumulator will be increasing. Okay, all right. So you can see that if you actually turn on the second input, you can see that the down counter will be true, right? Okay. Yeah. Now from 3, 2, 1, and then you can make the up again. All right. So this is very useful for applications such as car parking. For example, one car is entering the car park, so you can put it as the input here will be high. All right. So if one car exits the parking lot, yeah, you can give this one high. All right. So it will count down. Okay. So that's pretty much the essence of up and down counters.